Good morning, good afternoon, people. Whatever time it is that we end up doing this, it's afternoon for me, but I don't know when the lesson is or anything like that. Anyway, here we go. Hope you're fine. I hope you're keeping well. I hope you had a good night's rest. Sorry, just trying to get comfortable. Oh, that's so much better. Thank you. Trying to get comfortable. Right, so probability. Things are going to start to get a little bit tricky, but I'm going to try to break it down and make it as simple as possible. Today we are going to look at the and the or rule of probabilities, as in, what's the probability of something and something else happening at the same time, or what is the probability of something or something else happening at the same time. If we've got two events going on, what's the probability of event 1 and event 2 happening at the same time? So I'm going to try to explain this with an example. Through an example, we're going to look at both and try to see if we can derive the rules from the example. Let's consider two events that are going to happen at the same time. I am going to flip a coin and I'm also going to roll a normal six-sided dice. Okay? So I want to find what is the probability of rolling a 6 and, because remember, intersection in set notation means, so probability of rolling a 6 and a tail. What's the probability of that? Now that probability is going to be related to the probability of landing on a 6 and the probability of landing on tails. So my answer is going to have to be related to those two probabilities, isn't it? We know that on a normal dice, what's the probability of landing on 6? 1 out of 6. Okay. And the probability of my coin flipping it and getting tails, we know is going to be a half. So the probability of landing on 6 and on tails is going to be something. We're going to have to do something with these two probabilities. What are we going to do? But in order to answer the question and to show you where the answer comes from, so you hopefully helps you understand, I'm going to use something called, or I'm going to try to help myself with something called a sample space diagram. Sample space diagram. So here on the rows, I'm going to write down the possible outcomes of rolling the dice, isn't it? I don't know why I made it so big actually. Okay, so those are the possible outcomes of rolling the dice, and on the coin I could either get heads or tails. And I'm going to list out all the possible outcomes. So I could either get 1 and heads or 1 and tails, 2 and heads or 2 and tails, 3 and heads, 3 and tails. You get the idea. Okay. And sometimes in the exam, it may be helpful for you to actually draw a sample space diagram. The question may not ask you to do it, but you may find it helpful because one of the advantages of using a sample space diagram is that it lists out, it shows all the possible outcomes of the two events, the events being flipping the coin and rolling the dice, in a systematic, in an orderly fashion. Nice and neat, with no chance of missing out one of the possible outcomes, okay? So we were looking at the probability of landing on 6 and tails. Well, we can see that my 6 and tails is that there's only one way to do it. There's only one way out of all the possible outcomes, and the possible outcomes I've got 1, 2, 3, 4, 7, 8, 9, 10 is 1 in 12. So the probability of rolling a dice, getting a 6 and flipping a coin and getting tails, the probability is 1 in 12. The probability of something and something else happening, in this case, is 1 in 12. What's the link between that probability and these two probabilities there? Can anyone spot a link there? Right, well, the probability of 6 and tails, which is 1 out of 12, is the probability of a 6 times the probability of tails, because 1 in 6 times 1/2 is 1/12. So we can say that in general, the probability of A and B, so the probability of one outcome and another outcome happening, equals the probability of one times the probability of the other. And this is the AND rule, this bit here, which you need to learn. So the probability of something and something else happening, we multiply the probabilities together. This is only true, this only works, you need to be careful here, if the two events are independent. What do I mean by independent events? Well, I mean that the outcome of one event doesn't affect the other. In the case of the coin and the dice, I think it's clear that no matter what I roll on the dice, that's not going to have an effect on what I get when I flip the coin, okay? Whereas possibly later on, we're going to look at dependent events, whereas depending on what happens with one event, that's going to affect what happens in the other ones, and we'll explore that. But for independent events, and what did I mean by independent events? The probability of one doesn't affect the probability of the other. The AND rule of probability says that the probability of one event happening and another event happening is the product, the multiplication of the two probabilities together. Okay? Good. Well, that's it. That's it for the AND rule of probability. Okay, now we're going to talk about not quite two events, but two outcomes. So mutually exclusive outcomes. So mutually exclusive outcomes. So here's when, here we don't have two events like with the coin and the dice. We've only got one event, which is rolling the dice. And we've got the 6 possible outcomes of the dice, 1, 2, 3, 4, 5, 6, and the probability of each one, in this case, they are all 1/6, okay? Now, mutually exclusive outcomes means that if I get one outcome, the other ones cannot happen. And that kind of makes sense, doesn't it? If I roll a 4, I cannot roll a 3 or 2 or a 1 or a 5 or a 6 at the same time. And if I roll a 5, I cannot roll any of the other numbers at the same time. So if one happens, the other ones cannot happen. Okay, so mutually exclusive outcomes. Now, the OR rule, the OR rule of probability. So this is quite intuitive. You can get it. What's the probability of rolling a 5 or a 6? In this case, we're using the union. Is an OR, means union. So the probability of rolling a 5, you can just look at it. The probability of rolling a 5 or 6 is 2 out of 6. Oops. It's 2 out of 6, which is 1/3. We simplify. It's a 5 or a 6, so I could get 2 of those 6 outcomes. 2 out of 6 is 1/3. We know the probability of rolling a 5 is 1/6. we know the probability of rolling a 6 is 1/6. What's the link between these two and that one there? We add it together. So the probability of A or B happening is probability of A plus probability of B. And that is the OR rule of probability for mutually exclusive outcomes. And for now, I want to leave it like this. Later on, we will look at OR rule when we've got two events, like rolling the dice and the coin, and what's the probability of getting heads or a 6. But that gets a little bit more complicated, and I didn't want to go too far. So for today, I just wanted you to learn the AND rule of probability for independent events. So when the outcome of one event doesn't affect the outcome of the other. And I also wanted you to learn the OR rule for mutually exclusive outcomes. That's when we only have one event, which is rolling the dice. Getting one result means that you cannot get any of the other results. Okay, so that's for today. Please let me know if you've got any questions. Comment below, like, subscribe. God knows, whatever. Okay, thank you very much. Take care. I'll see you next time. Bye.